All right, today we are diving deep into the very heart of modern aviation. We are going to put the engines of the world's most popular airliner, the Airbus A320, head to head in a real engineering showdown. The Airbus A320 is an absolutely incredible machine. But what truly gives it life? Well, it's the engines. And here's something you might not know. Airlines actually have a choice. It is not a one-size-fits-all deal. They can pick from three very different power plants, and each one has its own story, its own design, and its own philosophy. So what exactly are these choices? And, how different can they really be? So let's meet the contenders in this showdown. It's really a story of two different eras. You've got the proven, reliable classic engine that powered the A320 for decades, and then you have two brand new challengers designed for the next generation of flight. On one side, we've got the IAE V2500. This is the workhorse that has been reliably powering A320s for years. But on the other side, for the A320neo, that stands for New Engine Option, we have two cutting-edge rivals, the Pratt & Whitney PW1100G and the CFM LEAP 1A. And listen, these are not just minor upgrades. They represent a fundamental leap forward in technology. Okay, for our first round, let's go under the hood. We're going to look at the very architecture of these engines. How are they actually built? And what does that tell us about their design philosophy? Because it's right here that we start to see the first major differences between these new challengers. So check this out. Both new contenders share this modern approach to engine construction. It's a modular concept. This diagram of the LEAP 1A shows that it's not one solid piece of metal. It's actually a collection of major modules. You've got the fan, the core, the turbine. So if one part has an issue, an airline can just swap out the entire module. This makes maintenance so much simpler and gets the plane back in the air way faster. And this table, this just brilliantly shows how two different teams of engineers can solve the exact same problem in completely different ways. Just look at the two Neo engines. They start off pretty similar, right? But then they diverge sharply. The LEAP engine uses more stages, more moving parts in its compressors and turbines. Their thinking is to squeeze every last drop of efficiency from the airflow using more components, even if that adds a little complexity and weight. The Pratt & Whitney engine, on the other hand, gets the job done with way fewer parts. So how does it do that? Well, it has a different trick up its sleeve, which is just a fascinating trade-off in engineering. And that brings us to round two. The reason Pratt & Whitney can get away with so few turbine stages is all because of its signature move. It's a piece of technology that completely, and I mean completely, changes the game. It's called the geared turbofan, or GTF for short. Now, in a traditional engine, the big fan at the front and the turbines at the back are all connected to the same shaft, so they have to spin at the same speed. But here's the problem. The fan wants to spin slow to move huge amounts of air efficiently, while the turbine wants to spin incredibly fast to generate power. They're always in a compromise. The GTF, well, it breaks that compromise. So how does it work? Honestly, the easiest way to picture it is like the gears on a bicycle. The turbine in the back, that's like your legs pedaling furiously. It spins at its optimal, super high speed. Then it connects to this amazing planetary gearbox, which steps down the speed and not allows the huge fan up front to turn at its optimal, much slower speed. It pushes more air, more quietly, and way more efficiently. It's such a simple concept, but the impact is revolutionary. And the results? Well, don't just take my word for it. This is straight from the Airbus training manual. This one innovation leads to a triple win: less fuel burned, less pollution, and a significantly quieter engine. That is a huge deal for airlines, for passengers, and for people living anywhere near an airport. So we've seen some major mechanical differences, right? Especially between the two new engines. But what's really fascinating is that underneath it all, they all share a similar brain. A powerful digital controller that is basically the mastermind running the entire show. This brain is called FADEC, which is short for Full Authority Digital Engine Control. Think of it as a super complex computer. It takes the pilot's command from the thrust lever, mixes it with data from dozens of sensors all over the engine, and then it calculates the absolute perfect fuel flow and engine settings to deliver exactly the right amount of power as safely and efficiently as possible. This schematic gives you a pretty good sense of just how central the FADEC really is. At its core is the Electronic Engine Control Unit, the EEC. You can see it taking in all these inputs from the aircraft and from the engine sensors, and then sending out commands to all the critical subsystems: fuel, oil, ignition, you name it. It really is the engine's central nervous system. And its job is absolutely critical. I mean, the FADEC is constantly protecting the engine from itself, preventing the rotors from spinning too fast, and always monitoring temperatures so nothing overheats. And notice that last point. It has two completely redundant channels, A and B. If one channel even hiccups, the other one takes over instantly. That gives you an incredible level of safety.
Okay, so we've looked at the architecture, the big innovations, and the digital brains. So what's the big takeaway from all of this? Why does this engine competition on the A320neo matter so much?
It matters because of this. Compared to the classic V2500 engine from the last generation, both new engine options, the PW1100G and the LEAP A1, deliver just dramatic improvements across the board. This chart says it all, really. A major jump in fuel efficiency and huge reductions in both noise and emissions. And that translates into real-world benefits that affect every single one of us. For passengers like you and me, it means a quieter cabin. For the airlines, burning less fuel means lower costs, which can lead to cheaper tickets. And for all of us, it means a smaller environmental footprint for every single flight that takes off.
So at the end of the day, there isn't really a single winner in this engine showdown. I mean, both the revolutionary geared design from Pratt & Whitney and the advanced materials and architecture from CFM are just incredible feats of engineering. The real victory here is the fierce competition that has pushed the technology forward and just made aviation better for everyone.
And that leaves us with one final, really exciting question. We're seeing the impact of geared turbofans and advanced materials right now, but this pace of innovation, it's not slowing down. So it really makes you wonder, what comes next? What kind of technology will be powering the airliners of tomorrow? The race for the perfect jet engine is far from over. Thanks for joining me.